طيب السلام عليكم ورحمة الله وبركاته. Welcome with a new clip set. Today we are resuming the talking about counting. I will assume that you saw the first video about counting principles. Today is only problems about counting, only problems, okay? I'll choose some problems that will cover most of the ideas that remaining with conditions and all the using of the other stuff. I wish that will be a benefit for you to get the idea of any question. And before, as usual, we start, I need you to like and share the video and subscribe if you didn't do that yet. If you have any comment about this video or any other one, please do so and turn on notification. Let's go right away into counting problems. Okay, with the first problem, to get benefit of that, please read the problem, try to stop that video, and then give it a try, and then solve it. Continue watching to see how to solve it. I might talk in Arabic in this video because most of the students in Egypt need that it to be like in Arabic and English together. Here, how many ways can the letters of the word ClipSat be arranged? Pause, give it a try. Okay. As we said before, we needed to determine if the order important, of course, because it has the word arranged. And also, is the repeating allowed? No, because if the repeating allowed this way, this will be infinity. So I have only these 7 letters and I need to arrange them. So I am going to use the combination, the permutation. So either you use 1, 2, 3, 4, 5, 6, 7, P7, or just factorial 7. Okay, because you are not allowed to repeat, or you can just assume that you have 7 letters in the first choice and 6 letters after, and 5, and then 4, and all the way to 1. Any one of these give you the correct answer, of course. Okay, how much is that? I don't care now. So I'm not going to use a calculator unless we need to use the result in a further solution step. طيب, next one. Okay, here, how many ways can the letters of the word ClipSat be arranged if the first 3 letters must be S and A and T in any order? So I need to start with 3 letters, only 3 letters, 3 options in the first 3 places, and the other 4 options in the other places. We are going to use all the 7 letters, but here dedicated for S and A and T. So this part will be 3 times 2 times 1 only. The remaining will be for the other 4 letters. So this part will be 4 times 3 times 2 times 1. You can write that, just multiply 3 times 2 times 1 times blah, 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 or factorial 3 times factorial 4 is good. Factorial 3 is 6, factorial 4 is 24, and find out how much is this. It will be 144. Okay? So separate between this, and then multiply all the available places here, or available options in each place together. Okay, next. Same way, but the word SAT this time in that exact order. So I need to start with SAT, but in that exact order means the first 3 letters, you don't have that much of options, it's just 1 letter available for each place. And continue like the last one. Again, to get benefit from this video, you need to pause before you listen to the solution in each problem. So it will be 1 times factorial 4, which is only 24 because you canceled the option of like exchanging the order in the word SAT. Next one, and again, pause before you try to solve. How many ways can the letters of the word ClipSat be arranged in the first, if the first 3 letters must be S, A, and T in any order, and the last letter must be A. Okay? Must be a vowel, sorry, a vowel. So a vowel means I or A. But here I don't have any other letter than I, because S and A and T will already appear in the first, and you are not allowed to repeat, because he said just arrange these letters. Okay, so you still have 7 places, but now this place is also have a condition. We are lucky because the condition is not overlapped. Like S and A and T in any order here is this 3 times 2 times 1. And the remaining, you go to the first letter and write 1 before any other. So the letter I is already for this place, no any other letter allowed to be at the end. We need a vowel. The remaining letters will be L, C, and L and B. Only 3 letters, so it will be 3 times 2 times 1 here. Okay, so this time it will be factorial 3 times factorial 3 times 1, which is 6 times 6, or only 36. Okay. How many ways can the letters of the word CLIPSAT again be arranged in if the first 3 letters must be SAT in any order, and the next 3 letters must be CLB in any order? Okay, it is the same like the question before. Here we only have I is the only available letter at the end. Okay, so no difference here. So if he dedicated I for the last letter, or dedicated other 3 values on the first, it's the same. Especially here, because this in any order and this in any order. Okay, so you have XAT here in any order, and then CLB here in any order. That will be 3 times 2 times 1, 3 times 2 times 1, and only 1 letter left, so it will be factorial 6. Just 6 times 6, or factorial 3 times factorial 3. Okay. Pretty like the first one, only different in the text itself, but the same solution. It might have a different solution if we have like a couple of more letters in the word, but according to these 6 letters or 7 letters, it's the same solution. Next one. How many different ways can the letters of the word CLIPSAT be arranged if the order and the placement of the vowel I and A cannot be changed? This is a tricky one. Pause and give it a try first. Okay. Okay, we have 7 letters here. Only 2 of them are restricted, I and A. When it comes to put them in the letters, it should be the vowel's position cannot be changed. Okay, it's a little tricky one. We have 5 letters or 5 places of letters here. 1, 2, 3, 4, 5. Okay, this is for the letters C, L, P, S, A, the non-vowels, the constants. Okay, so I have 5 times 4 times 3 times 2 times 1 to arrange this, or factorial 5. But we still need to dig this I and A in between them. Okay, how many places are here? Count. I might think in 2 ways. Either I and A will come together, so it might be together here, IA here, or IE here, or IE here, or here, or here, or at the end. So 1, 2, 3, 4, 5, 6 ways times factorial 5. If that happens to be I and A together, but he didn't ask to be together. So we still have another option. What? That I and A might be separated by some letters. So I and A will lie in any of these 2, 1, 2, 3, 4, 5, 6 places. So it will be choosing of 2 places out of these 6. I don't care about the order, because whatever the 2 places I will choose, I have only one choice to put I in the first, A in the second. So to continue that, if they are separated, the number of places for I and A will become now 6C2, and that also will be multiplied by factorial 5 for the other steps. Okay, so this will be 6 times 5, that can easily be written as factorial 6, which is 720. 6C2, it will be 6 times 5 over 2, or 3 times 5, which is 15. 15 times 120. Check for that. This is plus, of course, not minus. Plus, sorry. And see the answer yourself. Okay. So Y is the first part here. If the I and A together, here, if I and A are separated. If they are together, we have only 6 spots to put them. If they are separated, we have 6C2 of choices to put them. Whenever you put them, you have factorial 5 for the rest. So you need to multiply each case by factorial 5. Okay, with another one. Okay, how many different ways can the letters of the word ClipSat be arranged if the order of the vowels I and A can be changed this time? So their placement may be I in A or A in I, like the other word here. Just examples. Give it a pause again and a try, and continue to watch. Here, it's the same way of thinking, but I and A in each time can be changed in factorial 2 of times. So instead of just considering it once, it will be factorial 2 in extra for the last problem. So I go in thinking the same way. I have 5 letters with 1, 2, 3, 4, 5, 6 places to put I and A. Again, I and A may be separated or together. If they are separated, like, or if are together, we have 1, 2, 3, 4, 6 spots. In each spot, they can be put in order in factorial 2 of methods, and the other 5 letters in factorial 5 of methods. Or means plus. Again, it will be 6C2 because we have 2 spots now. We are going to place A and I in them, 2 spots out of these 6 dashes. And in each 2 spots, we can arrange I and A or A and I. That's a factorial 2 of methods. And for final factorial 5 for the others. So that will be twice the result of the previous problem. Okay, how many different ways can 6 letters of the word ClipSat be arranged? If there must be an equal number of vowels and the constants. Since I have only 2 vowels, so I have option of only 2 constants. So here I'm not going to arrange all the 6, just 2 vowels, 2 constant. I have 4 places, okay? So I will pick 2 places for vowels and then place the remaining for constants, okay? How many 2 places in the 4? It will be 4C2 to store these values of the vowels. Okay, the vowels I and A only, so can be arranged in factorial 2 of methods. And the other 2 letters also can be arranged in factorial 2 of methods. Okay, so if I assume that for vowels, it will be 2 times 1. If I assume the remaining here for constants, it will be consonants. It will be 2 times 1. And then which 2 for vowels? He didn't like require a certain position. So we have 4C2 of positions. So that will be 6 times 2 times 2. You can find that out, 24. Okay. If you have any like question about anyone, you can leave that in the comments. I can explain that in text. Now we are leaving ClipSat alone. We continue with some problems of other ideas. How many committee of 6 people can be chosen out of 8 men and 10 women? Pretty famous idea. especially in probability, okay? If we need 3 of each gender, so I need 3 men, 3 women, by how many ways can we choose this committee? The committee has no way to do with order in this text. So it will be chosen according to C. So I'm going to choose 3 of the men and 3 of the women, that's it. How many women? I have 8, so let's ladies first. 8 C3 multiplied by 8, sorry, number of men is 10 C3, okay? And that's it. If we need to consider the order in this committee, like if we are going like to make a team of like in order, a manager and a sub-manager, secretary and treasurer and whatever the positions, if the positions is important here, you continue by multiplying the whole thing here by factorial 6. But in this case, you don't need this part, okay? We will add this factorial 6 if the order is important or if he said something about positioning in the problem. If he didn't, so don't add factorial 6. If he need only the committee, stop here, okay? With another one. If you have 20 students in class and you need to divide yourself into groups of 4, by how many ways can this be done? 20, that will form 5 groups of 4, okay? Think, pause, and continue. So let's choose the first group. I have 4 students to be chosen out of the 20. So it will be 20 C4. What about the other 16? We will need to choose another 4 of this 16. So it will be 16 C4. What about the remaining 12? You got the idea. It will be 12 C4. What about the remaining 8? It will be 8 C4. And the last is only 1 group. You can leave 1 here or 4 C4. Anyways, 4 C4 equal to 1. Okay? This is how to do this. With another question. Car plates can be formed of 1 and up to 3 letters. So it can 1 letter or 2 or 3. Okay, that's 3 problems. Nice. And 1 and up to 4 digits. That's with the letters. Okay. So you know how to write that. It's a kind of like A, B, C, followed by 1, 2, 3, 4. That's the maximum size. Okay. And more conditions here. The letters can be repeated, but the numbers cannot. So you are allowed to repeat in the letters. You are not allowed to repeat in the numbers. So how many ways can you do that? So for letters, we'll assume that all the 26 letters of English alphabet are allowed. So I have either 1 position for letters. I will write positions of letters here and then the numbers in the other bracket and then multiply all the results together. Okay. The letters, if they are only 1 letter, it will be 26. If you have 2 letters allowed, it will be 26 times 26 or 26 over 2, and here 26 over 3. Remember this case, repeating is allowed and the order is important. Okay. But in 3 cases, because 1 or 2 or 3 letters, I'm not sure, it's up to 3. If up to 4, you will add 26 power 4. Now with the hardest part is about the numbers. The numbers are, the digits also 10 digits. It might be single digits. Of course, I can eliminate a 0 alone. So if it is a single digit, it will be just 9 options from 1 to 9. Or it will be 2 digits. You cannot start with a 0. So it will be 9 in the 10th place and another 9 in the second place. Why not 10 here? Because he didn't allow us to repeat. So the number used in 10th digit cannot be repeated again in the unit digit. So it will be 9 times 9. And 3 places. It will be 9 in the first place because 0 is not allowed to start with. And then 9 as a 10th place and another 8 for the remaining because you are not allowed to repeat. Final one, if they are 4 digits, it will be 9 times 9 again times 8. These are 3. So you have only 7. Sorry for that. Available for the last position. Okay. I hope you got this number part. Again, I have 4 places. The last one. Here, 0 is not allowed, so I have 9 options. Here, repeating is not allowed. So assume you already write 3, for example. So you have here another 9 options other than this 3. If you write 3 and the 7 here, so you have 8 options there, and also you will be left with 7. I hope this part is okay. Then you add this and add those and multiply everything together to get the answer. I think that's enough ideas. I don't want to go so far. Of course, we have much harder problems than that. I have some problems, I say, much harder in the section of counting and probability in the channel. You can revise them, and I'll keep adding problems like with a single problem per video. For the hard ones, it might be for the people who love the subject, okay? But for the SAT or ACT or EST, this level is more than enough. I hope you get benefit from that. And of course, don't forget to like and subscribe and share the video. And thank you very much, and see you in the next video. Enjoy. Hope you all the best. Bye-bye.